That's his invitation. Let's get screen centered and we'll start. So, a little bit about Paremus. We're a UK company, as mentioned, started in 2001. It's actually the guys started in the finance industry, so prior to that, spent 7 years at Solomon Brothers, City Group, and that sort of thing, so worked in the city for a few years. After the move down to Canary Wharf, we really decided we wanted to change, and so we decided to start a company, thought it was a challenge. Boy, we were right. Especially during the crunch in 2001, when the dot-com collapse and all that sort of stuff. But really, what we were always interested in was thinking about applications in a different way. So, during the years in the investment banking industry, we'd always sort of been hardwiring applications into the infrastructure in a very sort of static fashion, so stovepipe functionality. This hasn't changed over the decade that I've been in the industry, and we're still doing it over time. And really we wanted to try and build things which are slightly different, so adaptive scaling and sort of fluid type systems, and really all of the stuff we've been doing since then is a learning curve on how we go about building this sort of, and this led us to sort of where we are today. So, just one comment. This is a recent quote from Zapfig, so a New York analyst company, which we completely agree with. So we've been saying this for a number of years. There's been a lot of talk recently about SOA, ESB, grids, WS, all that sort of stuff. And yet systems we continue to build are just monolithic, just stovepipes, because the systems that have been out there for 20 years. And what should we be trying to do? We should be trying to build runtime infrastructures where the applications bind to the underlying infrastructure. They just run. The underlying infrastructure is just there. It's abstracted away. So, gone are the days of strategic middleware infrastructure, gone are the days of message queues that you use, whatever. It's there when the application's needed, and get needed. So, that can very simply sort of phrase what we're about. OSGi is a really important standard. Now, Dave's going to be carrying the bulk of this talk and talking you through OSGi in some detail. This is what it's about, and we'll look at it. But a couple of things about the background of OSGi. We think it's important because it starts by addressing dynamism locally. How do I dynamically deploy software components, wire them together, to create services, but grade components within that service dynamically, and strip the whole thing down and tear it away again. The OSGi community started not in the enterprise space, but in home networking, engine car management, and all these sorts of things in the late 1990s. And they're a very small set of tight specifications which allow you to do this, just this sort of thing. OSGi directly addresses things like versioning. What versions do I need to wire together to get the system to work? And how to put them together and take them apart again without ripping the whole system down with a nibble back into it. This is fundamental to OSGi, down industry JVM. It's a lot of restricted technology. So OSGi Alliance formed in the late 90s, 1990, to focus on standardising this. OSGi actually started life as JSR 8. So it actually came out of the Sun world. And the Sun habitually regretted that, and spun it out for the OSGi Alliance. IBM got hold of it, and driving it forward as a standard outside of the SCP process. And recently, Sun actually rejoined. Sun, basically driven by the market forces that are really pushing us, OSGi into enterprise, decided, fancy on board, and they're now a board member of the OSGi Alliance on SAP last 2 or 3 months. On 2 months, you want to know more about OSGi Alliance? So go to OSGi.org. Representation of most of the companies, and we'll touch on some of the players later that are actually driving point in the enterprise space, what they're trying to do, and what you'll see from OSGi later on down the road, and also what we're doing with it, and why we use it the way we do. With that, I'm going to pass over to David, who's going to basically present OSGi from 2 perspectives: the simplicity of it from the developer point of view, and the flexibility of it, the things you can do with it. And with that, I'll pass over to Shall I go and plug in?
No, you're right. Okay, so my name's David Savage. I'm working for Paremus for almost 3 years now, since like very long time now. We've been working with OSGi. I never even heard of working with Paremus, so I had to learn and apply. Actually, I'm sitting that month, so do some really pretty rich applications with it. So it's really simple stuff to learn and get going. The APIs I'm going to go through, I should give the majority of the APIs. Yeah, there are some code examples, but they're pretty small. If it's too small or anything else, then you can always go on lines and Java docs, anything else. So slightly like code just so you get a feel for how it works. Yeah, so I've been a software developer for 10 years now, mostly in banking and telecoms. And then there's a private company who's interesting stuff with Enterprise. So, with that, what does OSGi solve? OSGi is a technology for building modules of Java components. So Java is a basic deployment unit in standard Java. OSGi extends the idea of a jar into a bundle. And importantly, it came out of the embedded software world, where you've got things like home devices, all that stuff was going on in 1999 when video recorders were linked to power units for your lights and all those kind of really small level devices. What they wanted to do was in those kind of environments, they didn't want to be continually cycling the JVM to get new functionality. They wanted to have the JVM sat there, always run, never having to power it off or anything, and then always just being able to bring in new functionality, take out old functionality. What's interesting in that problem is you have to be able to deal with things like security. So if you've got multiple vendors employing code into the same JVM, obviously you have to be able to, one, deal with class labeling problems that occurs with that. Also, do you trust the bundles within your VM? So there's a strong dynamic model and there's a strong security model, which actually lends itself very well to enterprise environments. So it's kind of grown up, outside the enterprise environment. That's a provides a perfect platform for this sort of application you want to build. So a quick view of the OSGi stack. All the way through the stack, after you get off the hardware OS, that's just where you get basic. You've got the execution environment, which is your Java runtime. Modules, which are the deployment units, so you've got a reflective API to be able to deal with what it is to be a module, so you can, in code, you can inspect what's going on in the module. I'll go into some detail about that later. There we go. Life cycle, so you can, there's a full life cycle to installing bundles within JVM, starting and stopping, we'll go into that in detail. And it's actually what you probably, the term SOA gets banded around. OSGi was doing services like model, in the 1999s. So this whole thing of just POJOs and having interfaces to link together objects, not doing this whole, I mean, if you've got an embedded device like 15K of RAM, why do you want to have a JNS queue to send something across just to talk to two applications? The whole thing is literally very lightweight, adaptive platform. And going all outside of security, so every action you can undertake in OSGi container has security around it. Okay, so I mentioned bundles. What is a bundle? Bundle is able to turn the lights on. There we go. It's an embedded device, so we've got something going on. So yeah, bundle is just a jar file with management service. There's no like XML file to represent what it is. There's already a way of declaring extra information about the jar file. So they just use management service. So specifically what is a bundle? Remember off the top of my head. So a bundle obviously is being a jar file. You contain classes and resources, so images, that kind of thing. You can also contain classes, resources. So you can import and export classes between bundles. So this is how you get the dynamic class path between bundles. So you don't need to put all of your applications one siloed stack. Often when you build enterprise apps with EO files and WAR files, you end up with loads of functionality. In order to communicate to another EO file or WAR file, you end up going via a queue. Some of this to get communication on mobile web services, that kind of thing, just to get out of the situation where you can't send data objects between the two without setting up your whole enterprise stack. You put data objects in when the thing boots. Some detail about that later. A bundle can contain an activator. So a bundle just contains the classes. So an activator is kind of like the main method for this application. So you can then use an activator to provide services to the outside world. I'm sure there's two other things I've forgotten, but we'll move on and then we'll go into detail with these in the next couple of slides. Actually, obvious. So, yeah, the simplest bundle manifest that you can have is actually just the one in bold, which is on the top. So, the bundle has to have a name. That name should be unique in the entire universe. tracing is generally good. So that gives you, this is how you reference your bundle from your company, the thing that it does. On top of that, these are the ones I recommend you put in there kind of anyway. So you give it a human readable name, so you get a better idea of what it is. You get a description, which gives you more idea of what it does. And you get a version. Versions are very important in OSGi. I'll get into that later, but you can do things you just can't do in a standard JVM if you use versions. So I mentioned so you've got a life cycle. The bundle can go to 6 states. Go through it like this. So you come in, get the black box, obviously, the bundle is installed, and you move from install. That just means you've got a bundle, its classes are the jar's in the JVM, and the classes are sat there. You can't use it until the bundle is resolved. Resolving means is that if that bundle uses other classes, so say you've got some API bundle, that's a simple case because it doesn't need to import any other bundles, it's just providing classes to other applications. So that one will be automatically, after it's installed, it will be resolved. If your implementation bundle needs the API, you don't really want to include your API classes in the implementation, so you put them in a separate bundle and then you import those API classes. So that can't use until it's resolved. So then you have to put both bundles into JVM at the same time. You install one, you install the other one. That moves the second implementation to its resolved state and you can use it. As I said, you can start the bundle, which is effectively calling its activator. That then allows that bundle to provide services within the JVM. It goes into active after it's been started. You can stop it again, just tear down all the services it's providing. So the core of OSGi, it's some ludicrously small amount of JVM space of like 5K, 10K. So you can bring a JVM from 5K up to whatever complex applications you want to build, and then take it right back down into 5K. Just have it sat there doing nothing. So if you're doing that with a JVM, you also have to start the process, you can start time, everything else. And then finally, when you don't need the one manual, you can just get rid of it completely. There's no longer on your machine. So, bundle access. The bundle access, there's the best kind of look if you go into the Java look. The interface is pretty trivial, start and stop, which are fairly self-explanatory. The world's simplest use case, which is start it, say hello, stop it, say goodbye. That'll get the warnings. How do you mark that up? So we had the original symbolic name version. So you now declare the activator that this bundle uses. So when you say in your Equinox or in your OSGi VM, when you say start bundle, that's the start method of your activator call. You notice we now got an import package. So this is where I mentioned you bring in classes from other bundles, other parts of the JVM. This is saying I need to get the framework, the OSGi framework, in which hello world activator extends. So implement bundle activator, we import framework activator. So you need to declare to the bundle which packages you want to use when this thing's installed in the VM. So to go into detail on this sharing dependencies, import package stated it's a good pattern to use to keep all of your API bundles in one class, one jar, API classes in one bundle, and then have implementations use those. Why that's good is it means you can decouple the bundles from having to have a kind of spiral effect. If you want to use the API, you can just literally just install that bundle. If you want to use an API that it's exported from an implementation, then you might then need to drag in the bundles that implements. So it just means you can make these points in a graph. So you've got the nodes connected on a graph. I'll go into detail on this question. Another way of saying using classes, say requires bundles. This basically says if a bundle exports many packages, just give me all of them. I don't want to sit listing every single thing this one bundle provides. I think this came in from the Eclipse world. Eclipse is actually a nice chat application. It's cool. There's some slightly weird things around the size, but it does. It gives you the core of the fact you can install dynamically when you load plugins. You always get that Do you want to restart? Yes, no, maybe. Do you feel lucky with some of those things? Basically, because the Eclipse thing came out of a world where there wasn't this dynamic behavior. So depending on, they can't guarantee that the bundle has been written in such a way that it can be started and stopped. They can't guarantee that it's going to stop all this sockets and everything else. So that's why do you feel lucky? Yeah, that one's, you get the implementation is actually providing the API, and if you want to use some bit of Eclipse as one small section, you end up having to bring large sections of its kind of mass along with you. So it's just a nice way of organising things that you turn the lights on and off around there. Yeah, you've got APIs and implementation into separate bundles. So yeah, if you want to provide something to another, you export your API, you get a version here. I didn't specify on the import, I think previously there was a version. So this is saying, say you have log4j that you need to use from the environment, and you want to use some specific version because you use trace from something that came in after and all. So you need that version. In a standard Java environment, if you've got log4j in your class path, it's just going to pick whichever one it finds from the list of class libraries first. With this, you can say, well, my application needs version 1.1. And this one, in the same JVM, you can have two things using two versions. Yeah, you just annotate when you're building the thing to be deployed, you can say what your environment's going to look like. It's not like the action of how the sysadmin happens to have deployed your logic container. You specify it when you design how the thing works. There's an idea of lazy activation. So this is the activator gives you start method. You can sit there and you can program out, you can start up a OSGi container, and you can sit there and say start this, almost like a console. Another way of doing it, which is how things work in Eclipse, is most of the bundles are specified as lazy. So when a class is loaded, when any class from that bundle is loaded, prior to giving that class back to you, the framework ensures that the activity is started. So it means it's a more natural way of programming. You just say, I need this class behind the scenes, and they provide a bunch of sockets or something, or start a database connection to make the implementation actually do something, but it's seamless to the person who's using it. They don't need to know that. Here's one I want. Right, so it's something that you can't do in standard Java, but you can't have, is the idea of deployment. So this is the fact that this bundle can have internal libraries. So say in my Hello World application, I didn't want to, for some reason, I didn't want to use system.out, I wanted to use something else, say log4j. I wasn't going to provide that to the framework. I can embed that jar in this bundle, and that makes it available to your code and your code only. So if you have a private thing, you don't want to share with the rest of the world, you don't want to set it as a bundle, you just stick it in your local class path and put it inside the jar, and that means that will be available to you. You can also do a lot of things with native code. So I was going to look at what this is. QNX is some real-time operating system. This is because it came out of this comes from the OSGi documentation on the Zone Pixel. That's quite interesting. In this case, you can specify when this bundle is installed on this operating system, use this native code. When this bundle is installed on this operating system, use this native code. It's just one deployable unit. You don't need to sit there. Yeah, it's just become, the whole thing is about making these modules, which are self-contained and self-expressed, and you can annotate and go through them. So that's kind of what it is to be a bundle, what it can do. So I'll move on to slightly higher up the stack, which is the services layer. So OSGi shares services via an internal registry. You look up, query, add filters, list, and something, find out when new services appear. The registry is accessed via something called a bundle context, so we'll go into that bit. And services in OSGi are projects, they're just objects. Nothing, you don't have to extend anything, you can do whatever you like. You put this thing into the local registry, and you can find other things that provide services in your local registry. All the pass tokens have for you, just sit there and you can make applications that scale up to 5K to terabytes, and have it down again, and all this kind of thing. In all the projects. So what can we do with the bundle context? As I say, OSGi is an introspectable API. So anything you can do from the outside world, you can actually do with code. We use a lot of this for our infrastructure, which will be then hopefully moving on. Later on, so we can encode, say, get this jar from this web server, bring it across, it's just a URL connection, to drag it across the network, bring it in locally, install bundle and start. So encode, you can then start, you can activate services that make services that make services. It's just really, really impressive what you can do when you start using this pattern. You can look at all those manifestos, you can find out what's going on, and what is the status of bundle. So if this bundle has been previously downloaded, you can figure out, well, is it installed, is it running, is it resolved, can I use it yet, all those kind of things. I don't bother this and I think that's quite knowledge. We should go and look at the Java doc. You can listen for changes, you can find out when new bundles are installed. One interesting example where this was used, a guy called Peter Creans is one of the big people in the OSGi community. I've been there since it started. He gave an example where he had a bundle that contains PHP code, and his bundle would sit there looking for services that exported PHP or contain PHP classes of files. What it did is it sat there and goes, right, I found a bundle that contains that. I will load that bundle, start it, get its PHP files and dynamically add them to a server to my context. So the fact that you can listen to see what other bundles means, you don't have to write your application from the point of view of what other people are going to, what you want to do. You can sit there and listen for things that appear. So that is what's called the whiteboard pattern. So moving on, mentioned that it's a dynamic environment. A useful class if you're going to start writing with OSGi, you'll find pretty quickly is the service tracker. The service tracker just provides a way of finding which services, querying existing ones, or being notified when new services are joined. This is not bundles. The fact that the bundle has been installed, one bundle can provide many objects into the registry to be used. So using the service tracker, follows the code, hopefully we can read it. We've got, when this bundle is started, it's going to effectively look for a service called foo and call a method called bar on it. So it's looking, going the service tracker in the context, and it's saying, tell me when this class exists. The null at the end is for attributes. So you can say, if you have many services, if you have many database connections, you can put attributes to say this database connection is Oracle, this database connection is MySQL. These attributes allow you to not just look up something by interface, but you can annotate onto it the sort of things you're looking for. So that null is just an ANKL attribute, so I'll just give you that. Then, so you open the things, calls into the context to find any existing services. You ask for the service, get it, and call it. Notice the fact that it's not null, because depending on the order, when you start this bundle, maybe the other bundle that provides the service isn't actually being started, so you need to check that. A different way of doing that is to use, this is a way of finding out, not constantly have to poll the registry to find out when new services appear. You can add this sort of customizer, it's not a confusing name, but customizer does that to other things. Probably the most useful thing it has to do is find out when new services are added to the registry. So you can sit there and you receive an adding service call when the service is plugged into the registry, and you can then start using it. You modify it, means its attributes can change effectively, and removed, it has been uninstalled. Stopped and uninstalled. Very simple, I'm not sure why. Okay, so it's the service tracker, and this time you're passing in a customizer to receive the events when this foo appears. So let's try simple. I think I've gone through pretty much most of the APIs for the entire thing. Might have gone to a few of you because it was rushed through pretty quickly. But it's a simple API that allows you to do some really interesting patterns you can't do with the standard JVMs. And it's the fact that it came in at JSR 8. It's out there, kind of in the background, outside of everyone's radar from standard Java world. And we kind of crept up. And as I said, I've been working 10 years, never even heard of it. And suddenly it hits you sideways and you go, oh right, so you can build completely different applications you never would have even thought of. So when we start looking at why it's flexible. So this is just simple examples of the sort of things we do with it. with and add to it, whatever sort of things you'd like to build with it. So use cases, reach client mashups. The fact that you can install, uninstall code, single JVM, and if those things on, you've got all these plugins that can be installed, and you can interact with it in the same JVM. You can do kind of mashups thing, which people do with web services. You've got all this JavaScript. Where is that? Yeah, all of the stuff we use all this JavaScript to get all this quite quizzy things in a browser. But you're still having to kind of hack around the fact that the reason you don't do that generally in your client role is because it just never works without a modular system for deploying code. So this is a really interesting example, Eclipse being good, a real world situation when that works. Reusable enterprise components, as I say, quite often people end up building these silos of EO files and with queues and things to communicate between them. In order to make the comms work, to get the data objects to pass between them, you end up putting a silo together where you've got the web application server installed, boot the application server with certain data classes to allow it to communicate between. You end up changing that using this way, allowing them to pass between them, but it's just kind of all fudge, which really is getting in the way of when you're in one JVM. Why do you want to do all that extra fudge? You just want to get your job done. Multi-version deployments. So I mentioned the fact that you can use different libraries and different code. You just can't do that in standard Java. And that comes into its own when you've got things like change, which everyone builds their applications first time around, and then there's a bug, you have to go and redeploy it. And how the bloody hell do we get these two things running in the same server environment without closing it down with the fact that you were declaring in the bundle, I need to use this package with this version, the underlying framework, and just sit there and go, right, you're in your world, just sit there and communicate. So an example of that last one is unintended consequences. So yeah, multiple versions. You've got one section up here which uses some version of a jar. You've got another section which you go and edit, bug fix that has to go in the live environment. Traders in the fashion, do it now, you're back up. Yeah, you can. So the reason it works in OSGi is not a hierarchical class data level. So standard way of putting together our environments, everyone has learned for years, and we've all forgotten. I guess the reason we don't see this problem is we never knew there was anything else you could do. So we've got the boot class loader, provides the base level classes, the system class loader, and then you install all these EO files and WAR files using the URL class loaders or equivalent mechanisms to download classes. But what that leads to is this mess where one class loader tries and loads a class, another class loader, which is all generally done, seems to be by the application server. But suddenly you get this class and instance of this class, and this class is the thing which don't match because the identity of the class is defined by the class loader and the loader. So if you put your data objects in the EO stack higher up, then when you come and try and use them to send up one thing from processing all the data objects in one application and try to send it across to the other one, you just get all sorts of weirdness going on. So, OSGi, peer class going on. I was mentioning that briefly a little while ago, but again, removes the need to push these things down into your infrastructure to designing infrastructure to support the application. Infrastructure, you've marked out how you want the application to work. So this is the type of situation that goes. One bundle exports some classes, another bundle imports some classes. And I've got there the fact this other BAS bundle is exporting, but it's not going anywhere. One thing we start getting into when you have multiple bundles which are all exporting classes, it's quite possible. One developer's gone and written something that exports some XML content or something. Another one happens to have exported the same thing. Now, what happens with OSGi? Again, to solve this problem, it guarantees there'll only be one bundle that actually supplies that class. It's the same class and version, then it just sits there and goes, right, well, you're not needed. We're both supplying that class, just share the same object. So you don't get not equal to, you don't get not instance of. So, yeah, with that, I think I've gone through the
what we're going to do now is just look at sort of background, sort of turning on at the moment in the enterprise world, and then we'll go to why we really care about it all of it, which touches on some other things as well. It's probably another talk sometime. So, the OSGi Alliance sets up the enterprise working group September last year. The purpose of this group is specifically to concentrate on OSGi in the enterprise. So OSGi is coming into the enterprise, it's going to fundamentally change the way applications are run over the next decade, no doubt about it. The guys who are in this group, BA, IBM, the Foundation, Professor Leon, Leonardo, Red Hat, Oracle, SAP, all the stuff, and anyone missing is Microsoft. So everybody else is there. As we said, SAP and some joined recently, some having sold for many years because it was in the GSR8 and the politics going on there. Some of the themes for OSGi are released finally for next year, so mid-2008. So these are some of the RFCs that are in the process of being worked on at the moment, which make them out or, may slip through to some time later. It's quite interesting. Very interesting multi-language support. So OSGi isn't just about Java. We're looking at how to support other languages with it. And it's a very active area at the moment. No firm details on what's going on, but there's quite a detail out to obviously do things like Java and that sort of stuff. Pass loading and marshalling. Paremus has actually put a lot of work into this area and contributed to stuff we've been working on in our product set. Basically, how do you get OSGi to work nicely with RMI? How do you work around these problems of the standard hierarchical class loader that you come across in the Java RMI world with the peer-to-peer approach in the OSGi world? So this will be sorted once and for all in OSGi Release 5 and affects other things like using point like OSGi and other things.
I think the serialized logic, so not just remote communications, you put things down to a database and something like that. How do you use it?
Remote management of containers, state management of state in containers and support for JDI, JE, to put down the legacy technologies will be coming out in R5 and the OSGi release. One of the things it doesn't do, though, is support distribution. I'll touch on that in a minute. But before I do that, here are some of the frameworks which are now starting to use OSGi. Now, all of you will know Spring. Okay? Spring 2.5 is it? I can't remember. Yeah, 2.5. Spring Dynamic Modules is OSGi. So you can write Spring applications, written on Spring Dynamic Modules, and be using OSGi lots. However, they're not the only OSGi framework. Another one you may have heard of is the Google Juice OSGi framework. There's an OSGi version of that, which is produced by the open source group OSGi, and it's called Pilgrim. There is a OSGi framework on Apache under the Felix OSGi Apache project called Apache. Finally, a very interesting project announced at All-Dev a couple of weeks ago by Richard Ricardo. So started in JAVAWUG some time ago. There's another OSGi framework, domain-driven design-based OSGi framework. Again, supports OSGi. All the OSGi frameworks which come into the marketplace, both the leading one and the contenders in the future, are going to be using OSGi as one of the design mechanisms. Okay. Quote from SD Times, OSGi is probably the most important standard of the decade. I think we completely agree with that. I think OSGi really is relatively changed but all the major industry vendors and outside of most of the WebSphere, there's one huge OSGi bundle, the modules, drop it on a machine as OSGi, Lotus Notes is OSGi days, etc. If you want more information on OSGi, one of the people you might want to look up on the internet, Pilgrims, he's the technical director for OSGi Alliance and has been involved since the very early days. And so some excellent talks out there, presentations, well worth looking at in general. But there's a bigger picture. OSGi just at the moment addresses a single JVM. Okay? So we can install, we can change, we can install code in a very flexible dynamic fashion in a single JVM. But we want that sort of behavior across the enterprise. We want to build systems which are just as adaptive across the enterprise as OSGi in a single JVM. So how do we do that? And some of the questions we have to answer as we do that. So, how do we describe dynamically assembled systems that are running across really distributed compute nodes? We've got all sorts of modules that are a bit like Lego bricks in a bucket, take those software modules and build them into this sort of, this house or this whatever standards we're doing with out there. How does this system adapt to a changing resource landscape? What do I mean by resource landscape? Well, servers fail, servers are ripped out and decommissioned, new servers are added. And we want the system just to continue running and adapt to that. Life's like that nowadays. Things change. Why do we build systems which, gee, you never thought a server was going to fail, and it's disappeared. We want a system that adapt with that on a day-to-day basis. And how do we build systems that evolve? They're capable of upgrading the versions, changing the protocols they're using, the distribution behaviour, resilience characteristics. I don't want to build a stovepipe grid, connect it to a stovepipe ESG, put a stovepipe app server on the end of it, and run it on a set of stovepipe servers in the data centre. I want a system which can adapt and evolve and change as required by the business applications running across whatever hardware is available. And how do we do all that and reduce operational complexity? So it seems much simpler to roll out and manage relative to data systems. Those are the challenges we set ourselves. So move on there. So InfiniFlow, this is what we actually do. What is InfiniFlow? It's an enterprise service fabric. So, little phrase here there. And service fabric is built from the ground up using OSGi, another standard in the industry we're going to talk about today called SCS, Service Component Architecture. So this component architecture gives us a blueprint, it gives us a wiring diagram for how to wire virtual modules together. And InfiniFlow very simply is the following. You've got a set of commodity resources within the data center, which InfiniFlow dynamically discovers, and then it maps the OSGi bundles as defined by the SCA system descriptions onto these resources. It maintains those running systems that it dynamically deploys, and it changes in response to changes in the environment. If the resources change, InfiniFlow will make the appropriate adaptations and look for new resources and whatever. And if we change the content application, InfiniFlow will adapt and change in response to that as well. So InfiniFlow isolates the applications from failures in the infrastructure, and application business logic and middleware services are all dynamically deployed, instantiated, and ripped out on an equal basis. So there's no centralized middleware infrastructure, if you like, in InfiniFlow. It's defined on a per system basis, rolled out, and unrolled just like everything else. That's a big picture. The diagram here which shows sort of cartoon of the underlying fabric behaviour. So on the left-hand side we have a description of a system that we want to run. This description is actually a SCA Service Component Architecture deployment document called SCIDL. On the right we have the runtime entity which is running on resources. The basic behaviour of the fabric is to keep this balanced at all time. So what we have is 3 triangles, 5 diamonds, and on the left-hand side we have 3 triangles, 5 diamonds. What happens when the administrator changes the description of the system, the balance is broken. So the description for the runtime entity is no longer the same as the runtime entity. I now want 5 of these and 5 of these, or 6 of these and 5 of these, but I've only got 3 out there. The fabric actually responds by negotiating with whatever resource is there and deploying the extra resource out to bring the whole system back into synchronization. So the runtime entity can only ever be what the description is unless it's in the process of reconversion to that description. It's a nice little model because what happens is as soon as you start playing with this, you find out the failure recovery is just the other side of the coin. So now, on our fabric, we've lost a set of resources for whatever reason they've gone. So the provisioners say, okay, the system's good, oh dear, I've lost a whole load of components. What I'll do, I'll renegotiate with those out there. They will pull down the required resources, we'll wind back together, and we'll get the system back up to state again. So again, the basic idea being that the runtime entity, the stuff in the actual data center, is always driven back into convergence with the description of that runtime entity. And the operations and change control and all of this affect the model, not the actual runtime elements which are dynamically deployed. A fabric can support many systems. So a system is, you would imagine a business system, so order matching or back office or settlement system or whatever. So a system can be anything. A system is certainly composed of many components wired together, perhaps across many machines, and different systems running on the same fabric can have different characteristics. So the system on the left may be an in-speed-based system, enterprise service bus. Mule, that you'll be familiar with, is a dynamically deployable component that runs on the fabric. So we want to get the components in system 1 using MIL, for example. System 2 may be a high throughput setup, stage event-driven architecture, which is transactional. We may be using a completely different technology there, a space-based or queue-based system, and there's completely separate description for system 1 running. We can also expose, be able to surface these systems via SCA bindings in any way we like. They can look like services, they can look like global script systems, they can look like any sort of way we want to present them to the outside world. So what we end up with is an extremely flexible service, which looks like a normal service to the outside user, but it's very fine-grained, very dynamic, very flexible, and scalable in terms of its characteristics, intrinsic characteristics. So, who are we working with? So a few companies here that we've been working with, just to give you an idea. Quick Financial Systems, a high-performance resilience company, because they do front office, value at risk, pricing, these sorts of things. So they're actually using things for their distribution framework. They're using it pretty much as a standard grid in that case. Compare is a Web2 mashup company, so they have their robots that scale out on Fabric and drag stuff off from the internet. And reduce it down to various data formats. We're already working with them on a US government project, and that's really tried out a while ago about that. Neotech is a very interesting company, which is probably worth looking at if you're interested into say, structured data stores, rather than structured data stores like databases and unstructured data stores. So Neo is a very high-performance graphing engine, which connects nodes together in scale-free networking type terms. You can use it to traverse very complex structures very quickly. That one's on the Fabric. You may be familiar with Espotec, which is a complexity event processing engine set. These guys, again, as OSGi bundles are deployed on the Fabric, and we can wire these together in lots of the different services to create systems. Right, so what we're going to do next is to get down. Let's see what happens. So first of all, I need to break into this presentation for a second. And I need to get my screen back, so I just need to put on your So if you have any questions about the basic OSGi sort of stuff to the program level, please start with Dave. I want some nice stuff.
You mentioned, one of you guys mentioned, that there are problems, for example, with Hibernate. I mean, what sort of typical kind of common libraries? Hibernate is obviously a very commonly used library with a lot of applications. Are there lots of libraries like that, which basically, first of all, can you use it in OSGi at all? And secondly, if not, are there other libraries like that which you can't use in OSGi?
Okay, that's a good question. So what we ended up doing is we want to use RMI to internal communication, especially using G as the communication layer internally. It's completely seamless to what you see to the application beginning of just a project. The one thing is about marshalling. So what we've done with that is to customize the RMI class provider and the class as a plugin that allows you to figure out how to do it. So with Hibernate, I'm pretty good done it. Probably not. Hibernate, yeah, you can make that working. As I say, the R5 one is the one that really, if you're going to use it in a OSGi container without our additions. So what we ended up doing was, we basically provided back to the OSGi community what we ended up doing. So it's open source, so they can see it. And so that will be available in everyone's containers. And next year, we can work on that.
As it is at the moment, there's still those kinds of problems. I mean, obviously, you guys have a lot of experience in working with it, but I mean, just as
sort of problem
regular application.
Yeah. So in terms of, if your application, the thing is about, so if you're just going to deserialize any class from some file, you need to be able to get hold of the bytes that define that class. So if you do structure your handles so that the things that are being deserialized from Hibernate are in your annotated into your class, so you provide your handles to do it, then you can see them. What that doesn't get you is when the thread in RMI, when the thread that's driving that, what's a class there or something else, doesn't have visibility of the classes it's providing some external class. So it's acting as an intermediary. So it's a case of structuring things. I'm sure there's a lot of people, if you ask an OSGi dev or somebody, will be asked to come back and say, no, do this. So it's possible to do. You can do it now. It involves some kind of twiddling. We've got rid of those twiddles for our products. Yeah. So yeah, you can do it. It's perfectly possible to use like Paremus in your applications now. You start doing a bit of fiddling to make that thing really work seamlessly. It's possible to do. So yeah, that was a question.
Yeah, I have actually two questions for you. The first one is, if I'm correct, you can do service-oriented architecture with your OSGi, right?
Well, it's the fact the idea you've got the objects which have been discovered from registries as the user.
Okay, so if you are registering the object, you should have some process running all the time, is that correct? You know.
Depends on what the life cycle of your service is. So if it's just something that reacts to events, there might just be some object sat there. Basically, the object is available in memory for you. Depends what your service does. So if it's just something that takes the result of the service, does a process and sends back the result. That can be driven by a thread.
Okay.
Yeah, external application.
Okay.
Thread comes through the platform. If you're the sort of service that's pushing things down, so well, yeah, or you're trying to cache things in the background, you're trying to suck things up to provide them as a cache, suck them off at the space, slide them in, and provide them as an in-memory cache.
The second question is how, let's say I want to find some of your services and I'm outside your network. How would I'm outside your network.
Okay.
How would I go for that?
Again, that's not really, so the OSGi itself is an VM technology. So finding things, what they're trying to do with the OSGi 5 is the same model of lookup service. So when you use service tracker service, that's just going to seamlessly work to other OSGi containers.
I mean, in our product, we use Genie at the moment and then distributed.
Oh, I see,
So
okay.
we fuse basically Genie in with the OSGi capability.
Yeah.
Now, going forwards, we're sort of reviewing how we're going to move that itself. But it's quite interesting, the sort of the philosophical similarities between the Genie registry and the OSGi registry. It's one's distributed and one's local. We've been trying to get the River group to talk to the Felix group and all that sort of thing, but we've got it for a long time.
UDI and things like that, never really got off the floor. It kind of got this big standard that took forever to build and then use it.
Right, I'll just run through this. So, what I've done while Dave's been talking, we've got 6 Mac minutes here, and what I did was I kicked off a OSGi container. I think we're probably using Acronym on my laptop, and you can see that the container fired up, and we, at this point here, we have a running container. Boot complete. The next thing I did was I kicked off a subsystem called Atlas, which actually is a discovery mechanism that goes out and looks across the network for Atlas agents. Now, Atlas agents in Infinity are very, very lightweight native OS agents that just sit on boxes and you have to have someone here. And we discovered those. We discovered find out 6 actually. It's one of our nodes in the field to look today. Once I did that, I basically formed what we refer to as a resource domain. So we grouped those into a physical resource domain, and we said, right, let's boot in the fabric. And what you've been seeing here is those applications pulling down the base OSGi core framework of each node, firing up some services, and basically built out a distributed environment at the time we were asking 2 questions. Now, I've now got this guy here, which is our fabric and I'm going to connect into that environment. So, connect in. So there we go. We've got 5 Macs. These are some of the information flowing back from the Macs at the moment. Okay, and I've got a library. And this library is a repository that's running somewhere within these sets of machines, which stores all the bundles we're going to use for the applications and the documents, the SCA documents, to wire the bundles together. If we have a look at the moment, we see we don't have any descriptions for applications, and we've only got 3 bundles that we loaded during the bootstrap process. So what I'm going to do is I'm going to add some more. So what I'm going to do is a little fractal. It's very simple.
Can I interrupt you for a second? Do you use JMX at all in your OSGi?
Yes, all that management information.
All JMX. So what I'm going to do, I'm going to import all of those bundles into the fabric, into the repository that's running. Now these are the standard ones that we use on the unit side, actually. So select all of these guys, not going to be too finicky. You can see at the bottom of the screen saying adding resources. Not only are these bundles being pulled into the repository, but there's metadata checking of each bundle and metadata being created so that later on the graph can be checked for completeness when it's in the system. They can tell you all about that. I need another set.
So checking for completeness is the fact that you've got all these inputs and outputs, so you say you need it, and then what it's going to do is go, well, you didn't provide me the thing with regards to the API, how should I get on to start? So you can check that before you try and write an application. You can check. You can check for completeness. You can do this walking of the graph to find out what's going on, so how these things are going to apply together.
Okay, so I think we've got those in there. So now what we've got is just a whole bunch of OSGi bundles. Nothing to do with them at the moment, they're just sat there now in the fabric, so they're building blocks that I can build things with. So now what I need is a description for a system that I'm actually going to fire up on the fabric. So I'm now going to add a system. I'm going to go to demo, I'm going to fractal, work system, and I'm going to import this. So now we have a system called fractal workers. Look at the properties of the system at the bottom here. You can see we've got a number of components within here. We've got the actual worker itself. And then further down, we've actually got a space that we're using. So we're going to work with the space. The space is actually Dan Creswell's Java space implementation bullets. And the worker is actual fractal engine bundle. So that is the OSGi bundles. And we've got some parameters that we can dynamically change for the system. Okay, so again, we've now got a description, we've now got the bundles, and we've got resourcing. So what I'm going to do is basically deploy this to the fabric. When I deploy, what happens is we switch the metadata on this document in the repository, which changes the state from quiesce to runnable. As soon as it goes runnable, the provisioners that are running somewhere out there say, okay, this guy should be running. This thing out there at the moment starts negotiating. The nodes that are happy can set a source of components, will then pull the bundles down from the repository, instantiate them, wire them together, and everything will wire across the network. Right? Quite a lot goes on. So on the right, on the left here, you can see the target state. So the provisioners for the fabric are saying, well, I know there should be space out there, I know there should be workers out there. And what I'm doing is driving that back into convergence with what the document should be saying, which is, the system should be running. So now we're done. We deployed it. Okay, so we now have a distributed system running on these nodes that we instantiated from that document using the OSGi bundle to be imported into the registry. So we'll prove it's working, because I'll plug in a client. It's a little bit, I'll do this by firing a couple of bundles in this container, which is external to that fabric, so I'll do this Okay, so this is GUI. We have a look at Discover at the moment. And we're not bound, because we've not got an engine component we use on the client as well, but it's already found the workers out there. So I'll just add in the component.
I wish I did my forward presentation.
Okay.
Thank you very much for your presentation.
Pleasure.
Thank you.
So we're now down. Okay, so we've now wired our client into that distributed system which is running somewhere on that fabric. Okay, so let's run it. No surprise, it's a not optimised. So what we're really showing is basically the instantiation of a complex distributed system from just description and so that's basically all we're doing is negotiating with the runtime environment, whatever servers are out there, and then all components out, wiring it together to the source service. Now we've got another system